Okay, so this is chapter 4.2 about different types of networking media. We will start by looking at the copper cables, which could be cables like this, and of course also like this one, different colors, but still the same type of cables. When we are looking at the physical properties of a copper cable, we will see that the signals are sent as some kind of voltage or no voltage, high level of voltage to a lower level of voltage, but it is sent by current and voltage through a copper media. This means that it could be influenced from the outside, and we have different types of interference. It could be other cables, it could be just current running through a power cable, it could be other types of devices which emit electromagnetic interference, or EMI. And when we have a lot of interference, we can see that the bits in the signal could actually flip from a 0 to a 1 and from a 1 to a 0. And then, of course, what we are sending is wrong. So we need to make sure that we don't have a lot of interference when we are sending data through a copper cable. The different types of copper cables, we have the unshielded twisted pair, which is one like this, where we have the different small wires within, and they are twisted. That is why we call it a twisted pair cable. And we have a shielded twisted pair cable as well. And then we have the older versions of the networking cables, which are one like this, which is called a coaxial cable. But we will have a look at them. If we look at the UTP cable first, it's just 8 small wires that are twisted inside, and then we have a plastic jacket outside, and that's basically it. The reason why we twist them is not just because it looks nice, it's also because we have a physical law that tells us that the way of the current, the direction of the current in a wire like this will create a electromagnetic field. And if I reverse the current to the opposite direction, then the electromagnetic field will go the opposite way. So these two, when I send the current through these two cables, one in one direction and the other in the other direction, well, then what happens is that the two electromagnetic fields will cancel each other out. So I will not have no interference within my cable. That is why we twist them. In a cable like this, which is not protected from outside interference, we will, of course, it might be influenced by other outside electromagnetic interference. But sometimes if we protect them enough and put them in cable trays, well, then it might be okay to use a UTP cable, an unshielded twisted pair cable. If we look at the twisted or the shielded twisted pair, the STP cables is more or less the same thing, but we have a tin foil outside the pairs, and we could also have a tin foil protecting each and every pair. This is just to make sure that we protect them from outside interference. So that is a shielded twisted pair cable. The coaxial cable is an old type of cable looking like this. If you look inside it, it's not very easy. You can just see something white. We actually have a quite large copper conductor in the middle, and then we have different types of shielding outside. So this is a much better cable. It's much more expensive also because we have much more copper in it than in the thin wires of the twisted pair cables. But it is an old one, and when we use these types of cables, we didn't have a switch. All the different devices that were connected to the cable were connected to the same cable, which of course you could imagine could give us quite a lot of problems, because if I cut the cable one place, well, then all of the devices will lose connection. Instead of when I have like a switch here and have each and every of the devices have their own connection to the switch. So if I disconnect a cable here, only the computer that were connected to this will actually be influenced. But that was the coaxial cable. We need to take care of the cables. We need to make sure that we don't have interference. We need to make sure that we don't break them or cut them or otherwise make them not work. So we need to first of all make sure that we don't have the power lines and the cables running together, and we need to make sure that they are connected correctly, and we need to make sure that they are not damaged like this one, and we need to make sure that they are grounded correctly, otherwise we might also have problems in our cables. Yes, so this is the UTP cable. So no shielding when we don't really think about that we need to make sure that we don't have interference from the outside. It could be a good thing to use the UTP cables because they are the most inexpensive one, very, very cheap type of cable. We have different standards on these different types of both UTP and STP cables. We have different categories, and the categories will difference between the categories is, for instance, the number of twists that we have made, but also the quality of the copper. And the higher category, the better are the cables, and that is also why we can transmit higher on higher bandwidth on the higher categories. For instance, a category 7 and a category 5 and 5E and 6. Normally today we use category 7 or maybe also category 6. But this is just basically the quality of the cables. When we connect the connectors to a UTP, we use these RJ45 plugs, and then we connect. These will fit into the sockets, the UTP sockets here. Yep. Different types of cables. I think we already experienced, or I told you that there were different types. It's either a straight through cable or it is a crossover cable. Normally we will use a crossover cable when we connect two devices that are the same. For instance, two computers, two switches, two servers also could be connected with a crossover cable. When we are making a crossover cable, we're making them according to these two standards, T568A and T568B. A crossover cable will have an A in one end and a B in the other end, which means that the transmit on one end will go to the receive in the other end. Whereas when we connect or use a straight through cable, then we either have A in both sides or B in both sides. So both ends of the cable are made the same way. And actually transmit goes to transmit and receive goes to receive. But the devices that we are using this for will know, and they will just switch the signals. More or less new network interface card will also do that. So if you connect two computers by using a straight through cable, it will probably work anyway because the network interface card will know how to flip it. And that's also what's happening when we are connecting to the switch. We always use a straight through cable to the switch because the switch will know that the signals coming in is from a straight through cable. The last type of cable, which is also actually the same cable type, is the blue one that we are using to connect to the console. This is a rollover cable, and here all the small wires are actually just turned around 180 degrees. And this is a Cisco proprietary protocol. This is what we use to connect to the console cable on Cisco devices. But basically, it is the same cable. When we are testing the cables, well then, of course, we will see that there are a connection on all the different wires, and the type of tool we have to measure it will tell us also, for instance, something about the length of the cable, and is it postponed to have losses? Do we have crosstalk? Crosstalk, if I don't make it correctly, well then the small wires will interfere with each other, because when I put on my plug here, well then I need to unwire them, and if I have too much that is unwired, then I will have crosstalk in my cable. Here in the lab we have one of these here to measure the cables. When we are using fiber optical cables instead of copper cables, well then we will not need to worry anything about the interference, because nothing will actually interfere with the fiber optical cables, and the speed that we can send data through is much higher on a fiber optical cable. And the reason why we don't use it all the time is, of course, it's expensive. It's much more expensive than the copper cables. When we look inside the fiber optical cables, we will actually just have a small tube in the middle where we send the light in. And depending on whether we have a single mode cable or a multi-mode cable, the light will go either exactly just straight through on the single mode, or it will zigzag through the cable in a multi-mode. Because in a single mode we are sending pure light in only one wavelength, typically with a laser, and it's sent just straight through the cable. Whereas when we are using multi-mode, we are using a LED as a light source that will send out lights on different wavelengths, and we have like a mirror within the cable, and that's why the light will zigzag through. We can have much higher speed on a single mode than on a multi-mode, and the prices are of course a bit different also. The single mode is typically more expensive. The single mode can be, we can have large or the range could be very high, whereas the multi-mode it's more limited. And we have different types of connectors as well here. This is one, this is a S or a LC connector, I can see. So we have different types here as well. And we also have these tools that we can test the fiber cables. We don't have anything here in the lab because it's much, it's too expensive, and it's also very, very difficult to connect the cables or the connectors when we are using fiber optical cables. So normally we will just buy them. So if we compare it, well, we can see that we can have much higher bandwidth on a fiber optical cable. The distance that we can, the range of the cable, is short in copper media. Here we have a range of about 100 meters, and whereas we go to the fiber optical cable, we can have like the range like kilometers and more. The interference part, whether it's immune to electromagnetic interference and radio frequency interference, well, that is on copper media. They are not immune to interference, whereas the fiber optical are immune. We don't have any interference at all. Installation skills, well, it's much easier to install copper cables than fiber optical cables, and we don't really need to think that much about safety either. So the copper cables are simple and cheap, whereas the fiber cable are more complex, but also much better, but also more expensive. The last thing we can look at is where we use the wireless media instead. And of course, there are some concerns about wireless media. We have the coverage area, it's smaller. We have interference from all other kinds of radio emitting devices. And of course, the whole idea of the security. There are different types of wireless protocols. They all typically start with 802.11, and then we have A, B, G, not C, A, B, G, N, A, C, A, D, A, F, and so on. They're trying to enhance both the bandwidth and the coverage of these when we are using Wi-Fi or wireless media. Of course, also Bluetooth is another type of protocol that also can be used as a wireless connection, but is in a very small area. And then we have the WiMAX, which could also be done. It's typically by point-to-point topology instead. Yes, this is an example of a wireless router which has a built-in antenna. Here are some examples of the different 802.11 standards. You can see the bandwidth. The maximum speed is, if you go to 802.11a, which has a speed of 54 megabits, 11b, 11 megabits, and so on. You can see that there are very slow connections. And the frequency that we are using for the purpose is either 5 gigahertz or 2.4 gigahertz. 2.4 gigahertz is the frequency band that are free. So all other types of wireless devices will use the same frequency, and that's why we can have interference in our wireless network. You can see some of them are backwards compatible and some of them are not. And in class we will have a more thorough look at these different types of standards. And that's it for this part.